Hello and welcome back. Today we're going to talk about our old nemesis, R.F.I, or radio frequency interference. If you, like me, have recently purchased, well, for me it wasn't so recent, if you've just purchased your first linear amplifier or are considering making the big leap from 100 watts, you're going to find a whole new set of problems crop up. Because when you jump from 100 watts to 200 watts, doubling your power, you've gone up 3 dB. 400 watts is another doubling, there's 6. 800 would be 9. And 15 or 1600 watts, now we're talking 12 dB of increase of signal strength. And you're probably thinking R.F.I in the vein of television interference. Surprisingly, that's not likely to be your worst candidate. Today everybody is operating with cable television, and if the cable system's intact and properly set up and there's no leaking cable anywhere, the odds are pretty low of you getting into a television set. Far more likely you're going to interfere with somebody's stereo. The speaker leads act as an antenna. You're going to interface with somebody or interact with somebody's computer, you know, the mouse cable, the printer cable, all that crap, even the external speaker system. If it's a desktop, you're going to get into those. Those are fairly easily dealt with. By and large, the biggest problem that I encountered, I did have one television problem, and I got the cable system out here and made them fix the problem. That's another story. I had to show them how to use their equipment. Incredible. Anyway, well, let's not get off subject here. The biggest problem I had was telephones, and I've got about 5 neighbors within about a 200-foot radius of me. Fortunately, they are all great neighbors, and when I started putting the amplifier in, I went around and knocked on all the doors and told everybody I was putting an amplifier on my ham radio, and if they had any problems at all, do not live with it. Call me, log the time they had the problem, you know, exactly what time it was, what they were doing. I would check against my log and see what band I was on, and we'd fix the problem for them. Sure enough, as soon as I powered up the amplifier, every neighbor was telling me I was getting either into their telephone or into their answering machines. One neighbor had a fax system. I was getting into that. One neighbor, I had a computer that I was bothering, and one neighbor had a stereo, but all of them I was getting into the telephones. And I kind of expected this. Today's telephones, unlike the old POTS or plain old telephone system of many years ago, the old systems had a carbon button microphone. They had a wire wound earpiece, and they had a transformer inside that split the send and receive signal. It's called a hybrid transformer. And they were relatively immune to R.F.I. Today, everybody is using wireless handsets. And while the handsets themselves are not the problem, because they're usually up in the gigahertz, mine are 5.6 gigahertz, it's the base unit, the part that interfaces with the telephone line. It has audio amplifiers, and it interfaces with the little transmitter that's in there. Everything in there is full of diodes and transistors, and they just love to rectify RF and give you problems. So it's the base unit that's going to give you the problem. How do we cure that? Well, our old friend, the common mode choke, is the solution. And the common mode choke is very simple. It's just a toroidal core in this case with 2 windings side by side, and the telephone signal is a differential signal. The AC is going one way or the other, or these will reverse and it's going this way. The common mode choke has little, if any, effect on that. But when the RF tries to come in on both lines at the same time, that's the common mode. And the core of the transformer will absorb that or interact with that and block it. Now, nothing scientific about this. There's hundreds of treaties written on common mode chokes and ferrite and so on and so forth. This is not going to be a scientific discussion. This is going to be a simple how-to. Now you're wondering what kind of core I'm using. What's the material? Oops, and I just spilled them all over the floor. I have no idea. I bought a whole bag of these at the flea market. They're 2.5 microhenries per turn, and that's what I was after, a lot of inductance per turn. So if you've got a dozen turns on here at 2.5 microhenries per turn, you've got a lot of inductance. How do I make these? Well, I take one of these cores out of the bag. I take about, in this case, about 24 inches of wire, and I think this is number 26 enamel. I've never even checked. I don't care. I'm going to move the camera back here a little bit. Alright, now that the camera's out of the way, we're going to take the wire, and this is about 24 inches for the core I'm using. Your core may vary depending on the size of the core. You may have something much smaller. You may have something slightly larger, and I'll show you where size is important here in a minute, or where it may be a factor. So now that I've picked up all the cores I've spilled and put them back in the bag, we'll take one out. I'm just going to pass, we'll start with this end. I'll pass these two wires through here. I'll leave myself about an inch sticking out, and then I'm just going to start winding the wires through the core. And all I'm going to do, you can twist the wires together if you want. Some people recommend that. I find it works just fine, just passing the two wires through the core, winding them up, and I'll continue that later. But here's what you end up with. You end up with something like this. How well does that work, you say? Well, let me fire up the spectrum analyzer with the sweep generator, and we'll show you. Okay, we have the spectrum analyzer fired up. We have the tracking generator running. We have a marker at 15 megahertz and a span of 30 megahertz, so we're pretty much covering the HF band. And all I've done is take two cables, and let me zoom out a little bit here. There we go. All I've done is got two cables with alligator clips. Nothing very scientific, nothing highly calibrated here. We just want to get some feel for how much attenuation we have. And they're directly through my markers here. We've got 11 of we have a level of roughly 11 dBm. 10.92 dBm is passing through the cables. Now I'm going to break in and I'm going to put my inductor or common mode choke into the circuit. Now I'll try to separate the cables because we got a lot of leakage here. Now we have a level of minus 36.2 dBm. So let's call it 11 and 36 as our two numbers. So that means we have 25 dBm, or dB, excuse me, of attenuation, RF attenuation, just in this simple little choke. Is that enough? That's more than enough, because if you remember, we started out, let me get the camera stabilized here. We have gone from 100 watts to 1600 watts is 12 dBm, or 12 dB increase. Excuse me, not dBm, 12 dB increase in signal level, which was causing our problem. Now we have 25 dB of attenuation, so not only have we returned it back to the 100 watt level, we've gone the opposite direction, and all that's going to get into our telephone is down in the very, very, very low regions. Let's see, that would be minus, I'd have to pull out the chart, I can't do that math in my head. Needless to say, we've gone this direction, we've gone from here to an equal distance and the other way. Not very scientific, I know, but this is going to work. Now the next big problem is, how do we install this? We could install this inside the telephone. I would suggest you don't do that. First of all, you don't want to go inside of the neighbor's telephone. If something were to happen to the phone down the road, totally unrelated to anything you've done to the telephone, guess who they're going to look at as having caused the problem? So what do? Well, just about everybody has one of these laying around. These are old DSL filters. These were used on DSL internet or DSL modems for the internet to block the DSL signal from getting into your telephone. It blocked it from getting into your phone so you didn't have to listen to little crazy tones, and it kept your telephone from dragging down the DSL signal. These are simply DSL filters that went in line with your telephone, went in line everywhere except to the modem. The modem would get the DSL signal, your telephone would not. Most of these open very easily. This one I ran my thumbnail through it, and you've got a little circuit board inside. This one's the same thing. It was very lightly glued together. There's a similar circuit board inside. You've got some inductors. This looks like a much better quality one. There's a bunch of capacitors. There's some resistors. This one only has a couple of small capacitors and a couple of inductors. Here's another kind. This one's held together with a screw. That's fairly rare. And this one's held together with a couple of clips on the side that you're kind of going to need a little spudger to get in there for, or with, to break them loose. And I've got that side open. There, the other side popped. Same basic configuration. There's a couple of inductors and a capacitor. Any one of these is fine. Any one of these will house this inductor. So what I'm going to do is I'm going to take this unit, I'm going to remove all the existing components that are in here except for the telephone jack and the cable. I'm going to remove these two inductors and the two capacitors that are in here, and I'm going to mount my common mode choke inside. So we'll be back when that's done. Okay, and remember, when you're wiring this up, this is supposed to be common mode for the RF. So when you put your windings on, the two wires on one end go to the telephone, two wires on the other end go to the phone lines. That way the RF trying to get in is passing through a common mode filter. And once you've removed all the components from the printed circuit board, whoops, I'm going to kick the camera here, you just mount your choke in place of the components you removed. Phone line comes in here, or actually this will be the telephone end now. The phone line will come in here, go through your choke, come out the other side, go to the little stub connector. We put the housing back on this, and let's see, which way does this one fit together? I should have paid more attention when I took it apart. Do we have, it doesn't look like it matters. Looks like it'll fit either way. Yeah, I think it will fit either direction on this particular one. Some of them are a little bit fuzzy. That goes into the strain relief. A little bit of super glue to put the thing back together. Oops, I missed the... It's hard to do this looking through the camera. There we go. So now we have a unit. Very professional looking. You remove the cord from the telephone, plug this into the telephone, plug the cord that went to the telephone into the bottom, and you can even tell them this is a professional unit that you bought just for this purpose. That puts a lot of people's mind at ease that you're not doing anything to damage their telephone. You can say this was purpose manufactured for solving this problem, and that's the truth. That you just don't have to tell them that you manufactured it. Elegant, simple. The customer's not worried about you digging in, or the neighbor's not worried about you digging into his telephone. I have found this worked every single time. I've never had one of these fail. I've fixed several fax machines and probably a dozen telephone problems with these. These can be had. Ask your friends, ask your neighbors, ask your relatives if they have any stuff left over from the DSL days. And usually people are, we're squirrels. We stick stuff in drawers. I'll bet you find a dozen friends have these laying around, have no use for them, and just haven't thrown them out yet. And they're easily reworked into a professional looking filter that will solve your telephone RFI problems. So, Again, don't worry too much about what you're using for a ferrite core, something with a lot of inductance per turn. The wire's not critical, something heavy enough to work with easily and solder easily. The more turns you can cram on there, the better. It won't affect the telephone operation other than to clean up the R.F.I problem. Hope you found this helpful. If you did, please give us a like. Subscriptions are always welcome. They're free, of course. And as always, I'm the Radio Mechanic. See you soon.